We're going to look at an inductor that's in an AC circuit. And this particular circuit's in a radio receiver. The current amplitude through the inductor is to be 250 microamps when the voltage amplitude across the inductor is 3.6 volts at a frequency of 1.6 megahertz. And this frequency is at the upper end of the AM broadcast band. In part A, we want to find the inductive reactance that's needed in the circuit and the corresponding inductance. And in part B, we're going to hold the voltage amplitude constant, but we're going to change the frequency and find the current amplitude when the frequency is 16 megahertz and when it's 160 kilohertz. So let's begin with the diagram of the circuit. So here's our AC voltage source, which is held at 3.6 volts, but its frequency can vary in the problem. And here's the inductor that's tied across the voltage source, and of course there's an oscillating current through the inductor. The reactance of the inductor is given by equation 31.12, shown here, where omega is the angular frequency of oscillation of the circuit, and L is the inductance. The voltage across the inductor, of course, and amplitude is simply the amplitude of the current times the reactance. So in part A, we're going to calculate the reactance that we need for the inductor, and that's going to be the amplitude of the voltage divided by the amplitude of the current, and we get 14.4 kiloohms. Rearranging equation 31.12, we can solve for the inductance, where we replace omega by 2 pi times the frequency in hertz, which in this case is 1.6 times 10 to the 6, and we get 1.43 millihenries for the inductance. Now if we change the frequency, we're going to change the reactance, of course, but we don't affect the amplitude of the voltage. But the reactance is proportional to omega, so it's proportional to the frequency. And since I is equal to VL over XL, we find that I is in fact proportional to 1 over the frequency of oscillation. So at the given frequency of 1.6 megahertz, we had 250 microamps. So this current is going to scale like the frequency. At 16 megahertz, the frequency is 10 times bigger, so the current is 10 times smaller, which is 25 microamps. Correspondingly, at 160 kilohertz, the frequency is 1/10 as big, and so the current is going to be 10 times bigger.